Hi all, it's Rinat Stryungis from Circle, and today we are going to talk about the basics of laziness. We are going to see what is laziness itself, because it's one of the defining features of Haskell language. There are two main computational strategies, an eager strategy and a lazy strategy. In the case of eager strategy, and it's the most common strategy used in programming languages, we try to evaluate the arguments of functions before its application. And in the case of lazy strategy, we don't try to evaluate arguments before the evaluation of function application itself. Let's take a look at the very basic example, Boolean function end. Here we see a definition of the function, and let's try to apply it and evaluate it comparing the strategies. Here I should say a few words about a substitution. Evaluation of the function's application means that we substitute variables like LHS and RHS with specific arguments given to a function and then proceed. In the case of eager strategy, we evaluate arguments immediately and then apply the function, substitute arguments and obtain the result. In opposite, in the case of the lazy strategy, we apply the function first and then we define what should we evaluate now to go further. It is the first argument, because we need to choose the branch in the case expression. And voila! We have gotten the result, even without computing the second argument. Isn't it great? But postponing computations is only part of our laziness definition. Another part is sharing. What if we need to calculate the same expression a few times? We would need to remember the result to avoid useless calculations. And sharing literally means storing the result of a computation used in a few places. In our example, without sharing, we would calculate x twice. That is, laziness means delaying computations plus sharing. It's the definition of laziness. We've just seen the first three advantages of the lazy strategy. The first one is avoiding unnecessary computations, which could be really huge. We evaluate only what we actually need. We don't run into avoidable errors. For example, imagine that in place of the second argument we would have undefined or some crappy expressions containing errors, for example, but we don't even try to touch it in case of lazy strategy. So we not only save CPU time, but also prevent unnecessary errors. And the third one is that we don't evaluate the same expression twice. In our second example, x is just a link to the same field of memory. The fourth advantage of the lazy strategy is the possibility to work with infinite structures. Look at this example. We can define the endless list of numbers and we can use it as a usual value without any special functions or without any special syntax, because functions don't try to evaluate it without need. We can use infinite structures even in a recursive way. Look at this elegant definition of the Fibonacci list via itself. Zip with plus here just makes element-wise addition of two lists. Sometimes it looks not very useful, but sometimes it actually is. So it's the fourth advantage of laziness. But unfortunately, the lazy strategy has its own and significant problems. Sometimes it's very hard to use it, and in the next video we are going to talk about the problems and how to avoid lazy suffering. If you like this video and if you would like to see more such videos, then subscribe to our channels and press like button. Goodbye.